Imagine 7 billion people all at once, springing into the air in unison. What would happen if every human on Earth jumped at the exact same time? Would Earth itself feel the impact? Could we trigger an earthquake or shift the planet's orbit? The idea of a synchronized global jump is whimsical. It appeals to our sense of unity and curiosity. 7 billion people, each contributing to a collective bounce, is an image both awe-inspiring and amusing. Before diving into the specifics, let's set the stage for this global leap. We'll debunk some myths and dive into the potential consequences. So, let's lace up our imaginary jumping shoes and get ready to leap into the physics of it all. What forces come into play and how significant could our collective effort be? Let's break it down. Jumping might seem simple, but it involves complex physics. When you jump, your muscles exert a force against the ground. This force propels you upward. According to Newton's third law of motion, for every action, there is an equal and opposite reaction. So, when you push down on the Earth pushes back with an equal force, sending you into the air. The force you exert depends on your mass, and the acceleration with which you push off. For an average person, the maximum force exerted during a jump is about 1.2 times their body weight. Multiply this force by 7 billion, and you get an enormous total force. However, this force is distributed across the entire surface of the Earth, which significantly diminishes its impact. The ground might feel a slight tremor, but it's unlikely to cause any serious disruption. Now let's consider what happens if everyone jumps at home. Picture this: 7 billion people in their living rooms, kitchens, and backyards all hopping at once. The immediate effect would be a cacophony of thumps and bumps. But what about the larger consequences? When you jump at home, your impact is isolated. The force you exert is absorbed by the structure of your house and then by the ground beneath it. This localized force is not enough to cause any noticeable shift in the Earth's position. The energy dissipates quickly, and life returns to normal almost instantly. One might wonder if this collective jump could create localized earthquakes. However, the energy generated by individual jumps is far too small to trigger seismic activity. In essence, a jump at home would be a brief and amusing event, with no lasting impact. What if we took this idea a step further and gathered everyone in one place for the jump? Imagine a vast open field, packed with 7 billion people all ready to leap. The logistics of such a gathering are mind-boggling, but let's focus on the potential impact. Having everyone jump in one location concentrates the force. However, even with this concentration, the effect on the Earth would still be minor. The ground would absorb the force, creating a localized tremor. This tremor might be similar to a small earthquake, but it wouldn't be significant enough to cause widespread damage. The immediate area would experience a brief shake. Structures close to the jumping site might feel the tremor, but modern buildings are designed to withstand such minor shocks. The jump would be a shared moment of global unity, even if its physical impact on the Earth is minimal. Ultimately, the Earth is incredibly resilient, and would barely register the collective leap of humanity. Section 5. Earthquakes and Geographical Considerations. Geography plays a crucial role in how the jump would be felt. Different regions react differently to seismic activity. If everyone jumped in an area known for its seismic stability, like the central United States, the ground might absorb the shock more efficiently. However, in regions with high seismic activity, like the Pacific Ring of Fire, the effects could be slightly more pronounced. In seismically active areas, the ground is already under stress from tectonic movements. A sudden, albeit small, additional force from a global jump could theoretically trigger minor seismic activity. However, this is still within the realm of minor local tremors, not large-scale earthquakes. The variation in geography and population distribution means that the effects of the jump would differ depending on where you are. Overall, the geographical differences highlight how adaptable and resilient the Earth is. Section 6. The myth of global catastrophe. There are plenty of myths surrounding the idea of a global jump. Some suggest it could cause catastrophic earthquakes, tsunamis, or even shift the Earth's orbit. These ideas are more science fiction than science fact. Let's debunk these myths with a dose of reality. First, the idea of triggering massive earthquakes. As we've discussed, the energy from a global jump, while significant in human terms, is minuscule compared to the forces that drive tectonic activity. Next, the notion of causing tsunamis. Tsunamis are generated by underwater earthquakes or volcanic eruptions, not surface activity. Lastly, shifting the Earth's orbit is a myth with no basis in reality. Section 7. The ripple effect, minor consequences. While the global jump wouldn't cause catastrophic events, it might still have some minor, interesting consequences. One possible outcome is a temporary disruption to local ecosystems. The sudden thump of 7 billion jumps could startle wildlife. Birds might take to the skies en masse, and ground-dwelling animals might scurry for cover. This would be a brief disturbance, with animals quickly returning to their normal activities once the noise and vibration subside. Another minor consequence could be the effect on human infrastructure. Loose items on shelves could fall and sensitive equipment might need recalibration. These would be small-scale inconveniences, easily rectifiable with a bit of cleanup and adjustment. These minor consequences highlight that while the global jump wouldn't cause major disruptions, it still has the potential to create temporary localized effects. Section 8. Long-term environmental impact. Let's consider if there could be any long-term environmental impacts from everyone jumping at once. Given the brief nature of the event, it's unlikely to have lasting consequences. However, exploring this angle helps us appreciate the robustness of Earth's systems. One potential long-term impact might be on human behavior. The event could foster a greater sense of global unity and cooperation. If 7 billion people can coordinate a jump, what else could we achieve together? This hypothetical scenario could inspire real-world efforts to tackle global challenges, such as climate change and pollution. From an environmental perspective, the collective jump itself wouldn't leave a lasting footprint. The forces involved are too small to cause permanent changes to the landscape or ecosystems. The real long-term impact of the global jump could be psychological rather than physical. Section 9. Historical comparisons, group movements. History is filled with examples of large groups of people moving together, though not necessarily jumping. These events can offer insights into what might happen if everyone jumped at once. Consider religious pilgrimages, such as the Hajj in Mecca, where millions of people gather in a single location. While these events involve large numbers of people, their impact on the environment and infrastructure is carefully managed. Another example is large-scale protests or celebrations, like those seen in major cities around the world. These events can temporarily disrupt local areas, causing traffic jams and increasing waste. However, they are typically short-lived, and normalcy returns relatively quickly. Natural events like animal migrations also offer a parallel. Historically, large group movements show that while they can cause temporary disruptions, the long-term impact is minimal. Section 10. The fun factor. Why we love hypothetical scenarios. Hypothetical scenarios like the global jump capture our imagination. They provide a fun and engaging way to explore scientific concepts. But why do we love these what-if questions so much? Part of the appeal is the combination of simplicity and scale. The idea of everyone jumping is easy to understand, yet its scale is immense. It allows us to think about the collective power of humanity in a tangible way. These scenarios also offer a break from reality, letting us explore wild ideas without the constraints of everyday life. Humor plays a big role too. Imagining everyone jumping at once is inherently funny. This mix of humor and curiosity makes hypothetical questions uniquely engaging. Section 11. Conclusion. A surprising twist. So what if 7 billion people jumped at once? The Earth would barely notice. The forces involved are too small to cause significant changes. However, the exercise reveals much about our planet's resilience and our collective curiosity. The real impact of this hypothetical jump isn't on the Earth, but on us. Imagining such a scenario fosters a sense of unity and cooperation. It highlights our ability to come together for a common purpose, even if it's just for a fun thought experiment. Here's a surprising twist. The most profound outcome of this global jump could be the sense of global community it creates. If we can coordinate a jump, what else can we achieve together? This whimsical scenario serves as a reminder that, while we may be small in the grand scheme of things, our collective actions can still make a big difference. So, let's take this spirit of unity and curiosity forward.